Dynamic therapy. In sonodynamic therapy, again, we injected a non-toxic liquid to the patients, and the non-toxic liquid absorbed again by tumor cell. But in this case, we irradiate the tumor by ultrasound instead of light. Why and what is the benefits? What is the advantage of this? In case of photodynamic therapy, which is really good method for treatment of the cancers which they are in a cavity, for example, cancer in mouse, cancer in stomach, cancer in ovarian, or cancer in I don't know, for example, bladder, all the cavity inside the body. For treatment this kind of cancer in cavity, photodynamic therapy and sonodynamic therapy are the best solution, because you can put the laser by endoscopy to go inside the stomach and irradiate the tumor, or you can put the laser to by cystoscopy go inside the bladder, and it's very easy. And also for, I don't know, for ovarian or something like that. But in case of photodynamic therapy, because we have a sun, I means that we have a lot of source of light around ourselves. For this reason, if you use photodynamic therapy, probably based on the physiological property of the patients, some patients are very sensitive to sunlight after treatment. For example, in 1 day, 2 week, 1 week, 1 year, sometimes few years. So this is like a side effect. It means that the patient is very sensitive to sunlight. It cannot look at the sunlight. If the sunlight absorbed by skin, there is some erythema, there is some inflammation. So this is one of the side effects of photodynamic therapy. However, it's not a severe side effect, but it still can make some harmful. Okay, but in case of sonodynamic therapy, fortunately, we don't have a nature source for ultrasound. I means that if you go out, you cannot see a probe, but the ultrasound probe is not inside the road, in street, and something like that. For this reason, we don't have a natural source for ultrasound, so sonodynamic therapy is the less side effects compared to photodynamic therapy. But in both method, the difficulty is to find a liquid, because you need a liquid which it's not it shouldn't be very expensive. It shouldn't be toxic for normal cell, so it should be non-toxic. And also, when you inject it to the patients, it should come out from the body very easily after few hours, after few days. I means that you don't have to use a liquid which stayed in our body for few years. It's difficult, okay? But in this case, finding this liquid is a little bit different. However, we have a lot of liquids up to now which it's under the study for using as a trigger by ultrasound or by light. In this slide number 27, you will see the mechanism application of ultrasound. But before that, you should write a very important sentences. The biological the biological effects of ultrasound. What are the biological effects of ultrasound? There is two or three biological effects, which two of them is very important for me. But probably I can explain all the three biological effects of ultrasound. The first biological effect of ultrasound is heat, introduce heat. So ultrasound can create heat in our body, and it can increase the temperature of our body, which sometimes is difficult, sometimes is harmful. For example, in case of newborn child, or in case of in fetu, this increasing the temperature can damage the protein. For example, in million nerve cell, the temperature can damage to the protein, and by denaturation of the protein, the helix structure of the protein will be damaged, and it can produce some problem. But increasing the temperature is one of the biological effects of ultrasound. The second biological effects of ultrasound is cavitation. Please pay attention to this word, cavitation. What does it mean, cavitation? It's very long long history, and I will explain you in next slides, okay? But at this slide, you will see the third biological effects of ultrasound is produce free radicals. I don't know if you heard about free radicals or not. Can you tell me if you know what is free radical? Can you explain me a little bit? And and yeah, that's a good answer. And thank you very much. Yes, it was a good answer. But first of that, I want to explain you two simple sentences. We have a two phenomena in physics: ionization and radioactive. Ionization, do you know each atom is made of electron, proton, and neutron, okay? In a natural atom, it means that a healthy atom, like the atom of my skin, like the atom of your pencil, your paper, all the natural atoms have the same electron and same proton. So this is called neutral atom. Okay. Now, if you increase the electron, we should say ionized atom. And if you get electron from atom, you will say ionized atom. So ionization, it means remove or add electron to the atom. Okay, is that clear? The definition of ionization was clear for you? Yes, it means add or remove electron from the atom. Okay, proton or neutron we call radioactive. So this is a big difference between ionization and radioactive. So in radioactive, we can change the number of proton or neutron inside the nuclei, but in ionization, we just change the number of electrons, okay? So, in case of free radicals, we have a deficiency of the electrons. Okay, it means that you can remove some electrons or add some electrons to the molecule, and after that you have a free radicals, and we call them free radicals, as your friend says, oxygen species. Okay, reactive oxygen species, or ROS, or nitrogen reactive species, and NOS, something like that. Okay, so in case of ultrasound can create free radicals for you. How? By cavitation. So again, please pay attention to cavitation. Cavitation is a very important phenomena which is just happened by ultrasound. Why? Because some part of the electromagnetic wave and also mechanical wave are non-ionizing. Do you remember yesterday we talked about electromagnetic waves, and we start from radio frequency, infrared, visible light, and UV. And after UVC, we call this cancerous because after UVC, we have a ionized radiation, but before UVC, we have non ionization radiation. And also, before UVC and also mechanical waves are non-ionizing radiation. So how it's possible ultrasound can create free radicals? Because of cavitation. Because of cavitation. In case of sonodynamic therapy, as I told you, we have a non-toxic liquid which we called it sonosynthesizer. Sonosynthesizer, it means a liquid that can synthesize by ultrasound. If you irradiate this liquid by ultrasound, a lot of free radicals produced in the liquid, and free radicals can damage to DNA. And after that, as your friend says, can create necrosis, or I don't know, apoptosis for the cell, and can kill the cancer cell. So necrosis or apoptosis is caused by free radicals. If the free radicals like OH, interact with DNA, can damage to DNA. They can, and finally they can kill the DNA. Okay, in the next slide, number 28, I showed you a table which which shows that the different kind of or different types of cancer that you can use sonodynamic therapy for treatment them, and also in the left column I show the specific drugs which can use like a non-toxic liquid for sonodynamic therapy or sonosynthesizer. For example, look at the adriamycin. Adriamycin is a kind of antibiotic, and you can use it for sonodynamic therapy and for treatment of fibroblast cancer, kind of a specific kind of cancer which happened in bone marrow. Or also you have a, photofrin. Look at the photofrin. It can used for treatment of the cancer of HeLa, HL60. It's a name of the HeLa cells. It's like a some types of ovarian tumor in women. Okay, and also photofrin. No, no, it doesn't need to memorize the name. It's just for example. It's just for explain you how we can use sonodynamic therapy for treatment. You should just memorize that what is the mechanism of sonodynamic therapy or mechanism of photodynamic therapy. Okay, and also in slide number 29, I showed you this is the continuous of the previous table. Another types of liquid, you can study them, and also you can search in Google if you need more details or more information. But please look at the slide number 30. In slide number 30, which I made it myself, it summarized the application of ultrasound. Two property of ultrasound is very important: frequency and intensity. Do you remember what was amplitude yesterday? The amplitude I defined you very well. Amplitude was the distance between the 0 point in the curve in the wave up to the maximum point. Okay, it was amplitude. Amplitude will define intensity, and intensity it's defined how much energy that the wave have, okay, or the waves have. So in case of this table, I just try to summarize, categorized ultrasound in two category: low frequency, high frequency, low intensity, high intensity. Can you tell me where is the medical diagnostic or sonography? I means that which is the property of sonography: high intensity or low intensity, high frequency or low frequency. Can you find it in the table? Yes, high intensity and no, no, it's not high intensity. Please look at the table again. Medical diagnosis. Of course, yes, thank you. As you see in the table, ultrasound sonography or medical diagnosis of ultrasound is used high frequency and low intensity. Please note that low intensity is very important. But you will see in the other row, in the other column and row, there is a lot of application of ultrasound. For example, if you want to use ultrasound for massage therapy, what is the massage therapy? High intensity and high frequency. And also, you can use ultrasound for drug delivery. You can increase the penetration of the cell for a specific drug by ultrasound probe. If you use the ultrasound in high frequency and high intensity, probably you can make a cell more I mean that more absorption the drug, you know. It's like increase the penetration of drug inside some specific cell or some bacteria also. You can increase the penetration or increase the absorption of antibiotic for specific bacteria by ultrasound. Also, there is another application of ultrasound which we don't need it, like welding, cleaning, lithotripsy, and I don't know, engineering application. But I highlighted in red one of the important application of ultrasound. What is the name? I will give a positive point for the student Kabani. Yeah, I will wrote his name for make a extra point because very active and I like that. Okay, so yeah, sonochemistry. And for sonochemistry, we need high intensity as low frequency. So please note that if you want to use sonodynamic therapy, you should use high intensity and low frequency. So medical imaging by ultrasound cannot create free radicals. So it's not harmful for our body. Why? Because medical imaging use high frequency and low intensity, but for sonochemistry you need low frequency high intensity. So intensity is very important in case of production of free radicals, and it can damage to the cell. Okay, so this is what is slide number 30. And slide number 31, I want to explain you two important phenomena. Okay, two important phenomena. What does it mean? It means that by using ultrasound, you have a very, very important application, okay? Acoustic streaming and acoustic cavitation. These two phenomena is very important in ultrasound. What does it mean, acoustic streaming? If you put a cubic of sugar inside the tea, and you try to solve the cubic of sugar inside the tea, what are you doing for solving the sugar inside the tea? Can you tell me? What do you do if you want to solve a solid? Of course, streaming. So streaming, it means that, for example, it's very looks like when you want to solve a sugar inside the tea. It means that ultrasound can act or can work like a spoon. It can solve some solid inside the liquid for you. Is that clear? Because ultrasound can move the liquid inside together, okay, inside each other. So you can use ultrasound for solving liquid inside liquid, solid inside liquid, etc. It's really important. For example, in dentistry, the dentist used a small probe of ultrasound after the killing the nerve inside the root channel, they try to take out the nerve of the teeth, and after that the dentist put a small or specific liquid for clean the root channel, which this liquid is called bleach. It means washing the root canal, okay, root channel. And after that the dentist used a small probe because it wants to use as the probe like spoon, because it's not possible for dentists to put a spoon inside the root channel to streaming the bleach to reach the liquid to all part of the root channel. Okay, by using ultrasound this is possible because the streaming velocity by ultrasound is very wide range, from centimeter per second up to meter per second. It means that if you move the or if you shake the spoon inside the cup of tea, it's probably the velocity is just 5 centimeter per second. But if you put ultrasound probe, it can solve the sugar by velocity of 100 meter per second. It's very fast, and it can do it for you very fast. And the other phenomena is acoustic cavitation, which please let me to explain that very in more details in next slide. First, we want to show you the example for acoustic streaming as I showed you. After that, you have my PowerPoints. In the PowerPoint, the left image is a real video. You can look it at how this probe inside the root channel work. I just to explain that how dentists want to use this, because sometimes inside the feet, inside the root of the feet, we have some bacteria. This kind of bacteria has a biofilm around itself, so the bleach cannot kill this bacteria. And if you let this root with this bacteria, after finishing the dentist work, they can cause some infection, and it's very difficult for the dentist to take out the infection. But for this reason, before filling the teeth, normally the dentist use the ultrasound probe to kill the biofilm. If the biofilm killed by cavitation, after that the bleach or the liquid, which is NaOCl, can kill the bacteria. Okay. Do you think that sometimes when you have an infection in your throat, some people advise you to put some salty water? Did you hear that? Yes. Remember that the salt cannot affect it on the bacteria because it's not antibiotic. But in salt we have a sodium. Sodium can it's like a it looks like a rubber plastic, and it can damage to the wall of bacteria, and the wall of bacteria will be broken, and the DNA of bacteria will come out and the bacteria will die. So the mechanism of sodium in salty water is like that. It's just attached to the wall of the bacteria. It's like a rubber plastic, it's like a rubber metal, and it can damage or can scratch the wall of the bacteria and kill the bacteria. Okay, so this was the application of acoustic streaming. You can look at the movie after that, but I want just to explain you the acoustic cavitation and finish my lecture. Okay, what is the acoustic cavitation? Before explain these slides, I want to uh, tell you a simple word about cavitation. If you look at the glass of water, probably on the table or on your desk, you will not see anything. But if you put a probe of ultrasound around the glass of water or behind the glass of water, you will see some bubbles. These bubbles come out from the water, but it looks like boiling water. Do you know? It's if you look at the glass of water, you will see some bubbles, and you will think that this is boiling. But if you put a thermometer inside the glass of water, you will see the room temperature. You will see the temperature of the water is the same as the room temperature. So this is not a hot water. Oh, so the question is where these bubbles come from. These bubbles come from the layer inside the water, because ultrasound create cavitation. So what does it mean? Please look at the left image in bottom of the slide number 33. In this image, you will see that the liquid or the water, it's not completely liquid. If you look at the water by electron microscope, you will see water is made of different layer, which these layer are slippery together. And it's very similar to the blood is liquid also. If you look at the blood by electron microscope, you will see different layer of blood which slippery on each other. So we know that the ultrasound is a wave, and for the wave we have a positive peak and negative peak. What does it mean, positive peak? Positive peak in ultrasound, it means that the ultrasound compact all the molecule. But the negative peak, it means that ultrasound release the molecule. So the molecule can move around, can move in any direction. But in the positive peak, the ultrasound can compact or impact the molecules. Okay. So if you look at the water, if you interact the water by ultrasound, in the negative pulse, the layer of the water can be pulled out, can be distinguished by ultrasound. So normally in all the liquid like water, we have a small bubbles of gas like oxygen, like CO2, or etc. So in all the water, in all liquid, we have some gases which stuck between the layer. They trapped between the layer. And this undissolved or these unsolved gases can be released by applying ultrasound. So if you put high intensity and low frequency, remember that for sonic chemistry, high intensity, low frequency. This ultrasound wave can distinguish the layer of the liquid, and the bubble can come out. So if you return to my question, how where these bubbles come from in the glass of water, these bubbles come from because of ultrasound. And when the bubble come out, the remain place of the bubble is called cavitation, because there is something missing, and for this reason we called it cavitation. And also, if you look at the right figure in the bottom of the slide, sometimes we just don't have undissolved gas between the layer, but we have some dust, some small particles which trapped between the layer of water. For example, carbonate, oxalate, or other kind of dust which is exists inside the water. And ultrasound in the negative phase can distinguish or pull out the layer of the liquid, and this kind of dust, it contains some gas, and the gas can come out from this bubble. So pay attention that if you used high intensity in medical imaging by ultrasound, this kind of bubble can be released from the blood, and they can blow up the vessel, and the patient will be die. Okay, so this is very important. This is a very bad side effect. This is a very dangerous side effect of ultrasound. But as I told you, this is not happened in imaging, because in imaging by ultrasound we used high frequency, low intensity, so there is no bubble produced in the blood. That is that clear? So in the rest of the slides, I showed that how cavitation happen. Please look at the slide number 34. In the slide number 34, you will see in the positive peak of mechanical wave like ultrasound, if we have a dust, solid dust, some gas trapped in in the dust, and the positive peak push the gas to center to the dust. It means that it's just forced to the gas, and the gas cannot be released. But negative phase or negative pole of ultrasound try to pull out the gas. So if you continue the other negative poles, like I showed in slide number 34, 35, the other put, look at here, the first negative peak in the left try to pull out the gas, the second push it out a little bit more, but the third one release the gas. So this is the mechanism of cavitation. But why the mechanism of cavitation important for me? Because if you release the bubble inside the liquid, again the bubble can be affected by ultrasound. The positive peak try to shrink the bubble, the negative peak try to make a bigger the bubble, and again the positive peak and negative peak puts a interaction with this bubble, and during this interaction the gas inside the bubble will be hot. It will be hot, but it's too hot. The temperature is very looks like the temperature of sun, and the pressure is the high, about 1000 atmosphere. 5000 Kelvin is too much temperature. It can hydrolyze the water molecule. So ultrasound can create free radicals because high temperature happened during the cavitation, and this high temperature can hydrolyze water molecule. If you hydrolyze water molecule, it means that in water we have one oxygen and two hydrogen. If you hydrolyze the covalence bond between the oxygen and hydrogen, the hydrogen will be released, and we have OH and H, which both are the radicals, and they are very dangerous. And it's very looks like when you want to try to pump the air inside your tire of your bicycle or your ball. If you feel the pump, you will feel some heat, because you want to move the air by force to go inside the tire. It's the same that mechanism happen with the bubble inside the water. Positive pole, it looks like a pump. It's try to push the bubble to shrink the bubble to make small the bubble, but negative poles or negative phase of ultrasound try to make a bubble bigger. So this continuous smaller, bigger, smaller, bigger, smaller, bigger. And during this process, the air inside the bubble interact together and a lot of heat produced and the pressure go high and finally the water will be hydrolyzed and free radicals produced. This is the mechanism of how ultrasound can help us to make free radicals in synthesizer liquid and inside the tumor cell and kill the tumor cell. But imagine 1000 atmosphere is how much? If you have a small bottle of gas in your kitchen and which you want to use this small bottle of the gas for cooking, if you open the valve or if you open the valve of this bottle, you cannot hear the sound. It's a big sound, but remember that the pressure of the gas inside the small bubble in kitchen is just 2 atmosphere. So now suppose that when you have 1000 atmosphere, it's a huge pressure and hot temperature can hydrolyze water or other molecule easily for you. And this is the mechanism of cavitation. So you know that how cavitation can create free radicals. For this reason, in the slide number 37, I categorized three different regions. Number A, it's the in the center of the bubble which explodes. In this center, we have a hot spot, 5000 K, 500 or 1000 atmosphere, and the water molecule hydrolyze and OH free radical and H radical will be introduced. If you come out a little bit far from the hot spot, I means that, for example, 1 millimeter around the explosive bubble, you will see a second region which we called it gas liquid interface. The gas liquid interface is still hot temperature 2000 K but 1 atmosphere. However, in this region we cannot hydrolyze water molecule, but still the temperature is too high, so we can combine free radicals together. For example, OH free radical can combine with another OH and we can create a very toxic molecule, H2O2. H2O2 is not a free radical, but it's very toxic. If it's attached to DNA, the DNA will be damaged and the cell will be die. H2O2 it's a toxic molecule, can create apoptosis or necrosis. So if you create it inside the tumor cell, you can kill the tumor cell. So why I'm just talking about hydrolysis of water? Because 75% of our body is made of water. So the 75% of the space of the cell is made of water. So we have a lot of water. So ultrasound can interact with water and can hydrolysis the water molecule and also produce a lot of free radicals inside the cell. Do you understand? Still, can you hear me? Thank you very much. Thank you for informing me. Thank you. So, finally, if you just go a little bit far from this area, which we had a explosive bubble, you will see the temperature and the pressure is the same as the room temperature. It means that the ultrasound cannot evaporate your body. So the cavitation, it doesn't mean that all the water inside our body will be evaporate, because cavitation happen in 10 to minus 34 seconds. It's a very short time, really short time, and in this short time, the other part of our body which not damaged. So this is the main application of ultrasound. And finally, in slide number 68, which is the last slide, I shows many reactions which happen by ultrasound. Please look at the first line. The first line is H2O plus this. These are not bracket. This it means mechanical wave. Okay, it means ultrasound. So if ultrasound interact with H2O, we have a hydrolysis of water because of cavitation, and we can produce OH radicals and H radicals. Again, if the ultrasound interact with oxygen, we can hydrolyze oxygen, and some free radicals will be introduced, will be produced. Okay, and the other reactions, it means that when you have an ultrasound in synthesizer or in a non-toxic liquid interact with ultrasound, many free radicals produced, and sometimes these free radicals can combine together and they can create another toxic molecules like H2O2. By this way, we can use ultrasound for cancer treatment. This was all the things that I prepared to explain you in this lecture from yesterday and today. So again, if you had any questions, you can ask me. Again, I will please, if you record my voice, please share with your colleagues, with your friends, with the other students. And also, please ask your friends to send you all the slides, okay? And please let me know if you get or if you have all the slides. Again, if you have any questions from my three lectures, remember that the slides are in three lectures, okay? Lecture one, lecture two, and lecture three. And you have all the lectures, okay? Okay, thank you very much. Thank you very much. And thank you, Azaz, to send the slides for the other students. And thank you very much for your pay attention. Again, I'm so apologize for my delay today. And also, unfortunately, I was not be able to be in Kish in person. So again, I'm sorry about that. Uh, and also the attendance was recorded by the I think admin. It was not my duty, but something someone recorded how many students was and how many students was absent. But in any case, I hope these little things about ultrasound was be useful for you, and just I hope that it was good information for increase your knowledge about the application of mechanical waves in medicine as a diagnostic and treatment. So if you had any questions, you have my numbers, you can ask me, you can send me the direct, and I will answer all of your questions. And also, I want to thank you so much for your patience and for your being here. Have a nice day, and I hope you have a very nice time. Thank you very much, and bye.